Hello everyone, welcome to Code with Laya. Today we are going to learn the topic stack. Okay, we have seen what is stack during the introduction of data structures, right? Now we'll go into this topic in detail. Okay, so what is stack? Stack is a linear data structure. Okay, right? It follows LIFO, last in first out rule. Okay, so what is this last in first out rule? Consider, for example, you have a table over here. Okay, this is my 10th book. 9, 8, 7, 6, 5, 4, 3. Some you have like this. So consider these are my books on the table. 7, 6, 5, 4, 3, 2, and 1. Okay, these are my 9 books. So now tell me who placed the book on the table first? This 9th person, right? Okay. So I'm taking books and correcting each book. Which book will be easily accessible to me? This one, right? That means this has entered into the row, okay, last, but it comes out first. This is called last in first out. I've also set you this example. Contain a container. Let us consider a container. This is my first ball. This is my second ball. This is my third ball. You only have one opening this way. Okay. If you want to take it out, you will take it first 3 only. You won't be able to take this one because last in first out. Okay. Because it has only one end. Right. So this is what is the example for stack. So now, stack is a linear data structure which follows last in first out, and the most important part is stack has only one end. That end is called as top. You can insert or delete, either you can add elements or delete elements only from the top end only, right? It has only one end. Consider this is my stack. Okay, I have my stack capacity as some 5. That means I can store only 5 elements over here, right? Now, here you represent stack top. So this is my stack structure. Okay. Now, my stack has only one end. This end is for insertion and this end is only for deletion also. You won't go somewhere else. Okay. This is called as stack. Now we'll see what are the main operations on stack. First operation is push. Second operation is pop. Okay. First operation is push. Second operation is pop. What is meant by push? Push means insert elements. Pop means delete elements from the stack. Right? So, what does the stack do? It has only one end, and only that one end will be used for insertion and deletion purpose. That insertion and deletion are called as push and pop. Now, each time when you try to insert elements or when you try to push elements, top value is incremented. Each time when you pop an element, top value is decremented. Right? Okay. Now we'll start how to operate on stacks. So, what is my capacity? N equals to 5. I can store 5 elements over here. Okay. When there are no elements in the stack, okay, it is denoted by top value. Top is the most important part. You can say whether stack is empty or stack is full only with the help of top value. Okay. In case if there are no elements in the stack, top equals to -1. In case if my stack is empty and it is not containing any elements, my stack value will be -1. So what is the value of top here? -1, right? Now I will try to insert, or I will try to, so now I will try to push elements into stack. So what is this push operation? Inserting elements, and each time I try to push, my top should be incremented. Okay, now I'm trying to push an element, push 15. Okay, what did I tell you? Each time when I insert, top should be incremented. What is my top right now? -1, right? So now if I increment my top, it becomes top equals to top plus 1, right? What is my top value? Initially it was -1. So -1 plus 1 equals to 0, right? So this is 0th position, and the new element will be added at 0th position. Okay. Next, I'll try to push some 17. Okay. Now I try to push 17. So what is happening? So since there is space, top plus top equals to, it was 0, and I try to add one element, so top value is 1. So the new element will be added at 1 index. Okay. Next, I try to add one more element. My next element is some 42. Okay. Now I try to add 42. Now again top value is being incremented. Top equals to, it was 1 before, and I've added one element. So next element will be stored at 2nd position. So 42 is stored over here. Okay. I will try to add one more element. Push 31. Okay. So top was before, top equals to 2 plus 1 equals to 3. So 31 will be stored at 3rd index. Next, now I try to push again 62. Okay. So I try to push. So top value is 3, right? Top value is 3. 3 plus 1 equals to 4. Now the element will be stored at 4th position. Okay. So my stack is, at this point of time, my stack is full. It is containing 5 elements. Okay. Now I will try to push one more element. Push 79. Is there any space in the stack? No. So when top value equals to, what is top value here? 4. Array index is starting from 0 to 4, right? Total 5. Okay. When top equals to the capacity -1. That means index stops here, no? So what is my capacity? 5. So 5 minus 1 is n minus 1. This is n, right? So n minus 1 is 4. So if the top equals to already n minus 1, then you cannot insert elements, right? So this condition is called as stack overflow. Okay. First, we have seen top equals to -1. That means there are no elements in the stack. Now you are trying to push elements into the stack. Okay. So you have inserted 5 elements. The stack capacity is 5 and value is 5. So in case if you are trying to add more than 5 elements, there a condition arises which is called as stack overflow. That stack overflow condition is met at top equals to n minus 1. N means 5 minus 1. Okay, that's 4. Array index starts from 0 to 4. Right, over here 0 to n minus 1. So I've written when top equals to n minus 1, you cannot add elements or you cannot push elements into the stack. Okay, this is one of the condition in the stack. Right, so now we'll perform pop operation. Okay, so what is meant by pop operation? Deletion of elements from the stack. Right, say you have used a push operation. Okay, when you are trying to use the push operation, you are sending the values on your wish as parameters. But here for pop, you need not do anything because there is only one end in the stack now. So there is only one end in the stack. So you can access only the last added element. Right. So only the top element will be accessible. So you don't have an option to pick some element wantedly and you can't delete that, right? So you can only delete last inserted element. Okay, now we'll perform pop operation. Now, what is the last added element? 62. What is the top? 4, right? N minus 1. So you want to delete this element. You have deleted this element. Each time when I try to pop elements, top value is decremental. What is my top value at this point of time? It's 4. And what is 4 minus 1? It is 3. After deletion, what is the top value? This one. This is deleted. Okay. Now I try to delete one more element. So 31 is being deleted. What is the top value? Here, deleted element's top is 3. 3 minus 1 is 2. So after deleting this, 2 is the top, right? Now I try to delete 42 also. Okay. Now the value is, top is 2 minus 1 equals to 1. This is the top right. Right? Now I try to delete 17 also. So what is my top of 17? 1 minus 1 equals to 0. So after deleting this, 15 is left. Now I try to push elements once. Push 36. Okay. So now again value is inserted. Right? So now what happened? This was top before. This was top before. Now you have inserted element again. So again it becomes 1. So this is my top right now. Okay. So you can push or pop, you can perform push and pop operations simultaneously. Okay. Now I try to delete again. I try to delete this. Now what is my top? 1 minus 1 is, so this is the top right. Okay. Now I try to delete this element also. Now, is there any other element over here? No. So when it is 0, minus 1 equals to minus 1. What does this top equals to minus 1 say? Stack underflow. Okay, stack is empty. You cannot delete elements. Okay. So if stack is if top is minus 1, that means that there are no elements in the stack. Stack is empty. Okay. Now already the stack is minus 1 and you try to pop elements. Again you perform pop operation. What happens? So automatically when you try to pop elements, when the top is already minus 1, the bucket is already empty. Now you are trying to pour water outside. Is there anything to do over there? Nothing is there, right? Then there is a condition arising. Stack underflow. When top equals to minus 1 and you try to pop, right? Again, when for stack overflow, when top equals to n minus 1 and you try to push elements, right? So this is what is called as stack operations. Okay.